Alright, in this video I'm actually just going to do some note talking about polynomial functions, and then maybe we'll look at some examples at the end. So first off, kind of breaking down what a polynomial is. It really just means the poly part means many and the nomial part means name or term. So a polynomial function is just something that has multiple terms, and actually we kind of consider almost any function polynomial as long as its base has an x, as long as the variable is in the base. We will kind of consider it a polynomial even if it is single termed. So right here off the right hand side I have kind of put an example of a polynomial. So for instance, 5 plus 3x plus 3 times x to the third minus 2x squared, that would be an example of a polynomial. Now with polynomials we kind of have some different standard form and general form and different things we need to know about them. So for instance, with standard form means that the terms are written in descending order of exponents from left to right. Or in other words, another way of putting it is the exponents that are on each term should run from greatest to least. So for instance, if I were to look at this example back up here, notice that the exponent, the greatest exponent's in the middle, it's not first, so this would not be in standard form. I could rewrite this in standard form by putting the greatest exponents first and then line them up so that the least one is to the last or to the farthest right. So for instance, if I want to rewrite this in standard form, it would be 3x to the third minus 2x squared plus 3x, and then finally plus 5. Now some other general information to know with a polynomial in standard form, or even if it's not in standard form, we have terms such as degree of polynomial. We'll normally say that the degree of the polynomial is its highest degree that it has. So for instance, this polynomial would be degree 3. And then we would also say something about its leading coefficient. And the leading coefficient is the coefficient on the greatest power. So in this case, the leading coefficient's on this x to the third. And once again, that is 3 as well. Okay, so we have a leading coefficient of 3, and it's also degree 3. Now, just for some more information about polynomials, we also have what's known as general form. Now, I know if this is your first time looking at math notation, that this can look pretty nasty, but really what this is saying is that a function that's a polynomial will be in this descending form. Notice that the an minus 1, the a to the first, and the a to the 0, those are basically your coefficients. That's like your 3 here, your negative 2, your 3 there, and your plus 5. We just denote it with a to the n, but really each of those are just representing a coefficient. And then likewise your n minus 1, your x value, and then no x's. That's really the same thing as what you're seeing here, where you have x to the third, x squared, x, and then no x's. So don't get confused or bottled up with this notation. General form just means it's kind of in this orderly fashion. Now I'd like to take some time to look at a few examples of using these ideas to tell us a little bit about polynomials. So for instance, these problems want us to find the degree, the type of polynomial, and the leading coefficient. So for instance, if I look at this first example, I have f of x equals negative 2x to the third plus 5x plus 8. Remember that the degree is just the greatest degree that the polynomial has. So in this case, the degree is going to equal 3. And then for the type of polynomial, there are several different types that you can have based on degree. So for instance, if I have a degree of 1, we call those linear. linear polynomials, if I have degree 2, we call those quadratic. If we have degree 3, we say they're cubic. And if we have degree 4, we say they're quartic, and so forth. So for instance, here we have degree 3. So if I wanted to say what type of polynomial this is, well, I'd go to the third one. It's going to be called cubic, is going to be the type. And then lastly, we want leading coefficient. And once again, the leading coefficient is just the coefficient that's on your greatest degree. So in this case, it's the -2. So my leading coefficient is going to be -2. Alright, looking at the second example then, I have g of x equals -0.8 x to the third plus radical 2 x to the fourth minus 12. Notice that this polynomial is not in standard form, and actually the biggest degree is the middle term. So my degree is still the greatest exponent, so in this case it's degree 4. The type then, the type of polynomial I have is based off of that degree. So if I look at my list, I see that I have degree 4 is quartic, so my type is going to be a quartic polynomial. And then lastly, if I want to find that leading coefficient, it's going to be that coefficient on the biggest term, and in this case the leading coefficient will be the square root of 2. Alright, and then just lastly real quick, I want to look at the third example. So in the third example, I have k to the x is my function equals x squared plus 3 to the x. Now the thing to notice here is that this x is acting as an exponent. And this is really where our notation from above becomes important. So if you look at this notation for a second here at the bottom, you'll notice that all our exponents have an n, and you'll notice that all our x's in our notation, so every single x we see here is always going to be a base. So if we go back to the example for a second, you'll notice once again that this x is not a base, it's an exponent. So the first thing to notice about this is that this is not a polynomial equation. And since it is not a polynomial function, answering the questions about its degree, its type, and its leading coefficient make no sense here, so we just don't need to answer those. It's just NA is not a polynomial function.